Hello and welcome everyone. So I want to do this quick little video. This was actually a request on my Discord that how you can send some custom data from your attribute class to your character class and subsequently use it inside of your blueprints to do further processing. And I just want to point out that my original project was corrupted and I couldn't repair it, so I have set up a new project. There might be a few changes inside of C++ and blueprints, but most of it will stay same. So in this example, what I'm going to do is actually apply a speed debuff to our player character. So when he walks over a certain zone, his speed is going to reduce. So to start off, just open up your base attribute set class. I have mine open already. So first what I'm going to do is actually create an attribute for speed inside of my attribute class. So I'm just going to copy this and paste this, and then just simply call this speed multiplier. Okay, like so, and let's just copy this over here as well. And now what I want to do is, instead of using this default delegate, I'm going to create my own delegate and send this speed multiplier to my character class. Now think of the delegates like you have those event dispatchers inside of your blueprints. So one is a broadcaster and another is a listener. So what I'm going to do is actually just above this U class, I'm going to create a new delegate that I'm going to use to broadcast this data. So the way you do this is say declare dynamic multicast delegate, and then I'm going to use the variant 2 params because I want to send 2 parameters from here. And the syntax for this is, first you declare the name for the delegate. So I'm going to name this FATTR change delegate. Okay, next I want to tell what types of arguments I want to pass. So first is going to be float, and what is going to be called is speed change, speed multiplier, and I am going to call an int32 the second argument, and it's going to be called stack count. Okay, so this is done, and now I want to actually create an object of this type and just above this post gameplay effect execute. So I'm going to say FATTR change delegate, and I'm going to call this speed change delegate, this one. Okay, so this is done. So inside of my CPP file, what I'm going to do is actually test for the speed change and then broadcast the data. So I'm going to say if data dot evaluated data dot attribute is equal to my get speed multiplier attribute. So if this is true, first I'm going to do, like always, clamp the value. So I'm going to say set speed multiplier and fmax and clamp. Oops. Math, what's happened? Clamp, and I'm going to clamp this value, say get speed multiplier, not the attribute, get speed multiplier. Okay, and I'm going to clamp this between 0 and 2 because this is a speed multiplier. Okay, next what I want to do for the stack count, I'm going to say declare new variable int32 speed stack. Okay, and I'm going to say data dot effect spec dot stack count. Okay, and now I want to send these two variables using our delegate. So I'm going to say speed change delegate dot broadcast. I'm going to broadcast this get speed multiplier and my speed stack, this one. Okay, so this is done. Now our attribute class is going to broadcast this data whenever a gameplay effect changes this speed multiplier attribute. And now what I want to do is create a listener inside of my base character class. And first of all, what I want to do is define the functions that are going to handle this, handle as the listener for this broadcast. So first what I do is create a function. It's going to be U function, empty U function, because this is the requirement for the delegates. So what I will do is say void and say on speed change native Now strictly speaking, this is not a native function, but just to differentiate it between the C++ variant and the Blueprint variant, I'm going to just rename this to onSpeedChange native, and this is going to take the same arguments as float, and I'm going to call this speed multiplier, and the other one is going to be int32 and it's going to be stack count. Okay, and then I'm going to create the Blueprint variant for this. So this is going to be Blueprint implementable event, and category will be base character. Okay, this is going to void on speed change. Rather native is going to be simple speed change, and it's going to take the same arguments. It's going to be speed multiplier, and next one is going to be int32 stack count. Okay, semicolon. Oops. Okay, this is done. Now this one is going to have an implementation inside of my CPP file, and this one will have an implementation inside of Blueprint only. Okay, why is it giving error? Let's create an implementation for this, and over here I'm just simply going to call my native function and pass on these, sorry, not the native function but the Blueprint function, and pass on the arguments speed multiplier and my stack count. Okay, this is done. Now to actually create the listener for this broadcast, inside of my CPU file of base character and inside of my begin play, just after these lines, I'm going to create a handler for this. So it's going to be base attribute set component, and I'm going to say speed change delegate dot add dynamic, and this is going to say this, and the function for this is going to be ampersand a base character and my on speed change native. Now there's a little bit of problem with this. I cannot set this inside of my base attribute set component because this is being declared as a const function, a const pointer. Now those of you unfamiliar with C++, a const is a promise to the compiler that I'm not going to change this variable in any source. So basically I cannot change this variable over here like this. So to get past this, I'm going to use something known as const cast. So this is basically used to remove the constness, I would say, of a variable. So the way you do this is say const underscore cast, this one, and start with the angular brackets and say u base attribute set pointer, and I'm going to pass in my variable inside of the brackets and add a semicolon at the end, and I think this is done. So now what's going to happen is some gameplay event is going to change my speed multiplier, and in turn this is going to call this post gameplay effect execute, and once this is called, it's going to check this and then broadcast this speed multiplier and speed stack. And over here my base character is listening for this speed change delegate, and this is going to in turn call this native function, and that native function is going to in turn call my Blueprint variant of this on speed change. Okay, so let's go ahead and compile this, and once the compilation is done, we're going to return to the video. Okay, so the compilation has succeeded, and let's go back to our engine, and just to demonstrate the functionality, I'm going to create a few blueprints that are going to act as my speed debuff zone. So I'm going to create a new folder env and create a new blueprint class of the type actor. It's going to be bp speed debuff. Okay, and open this up, and I'm going to search for a plane, and I'm going to change the size to 1.5. Okay, and I'm going to search for a box collision, and this is going to be child of this, and change this to 75 by 75 by 40, 75. Okay, so now what I want to do is create an event for begin overlap. I don't need these. Okay, so once the actor has overlap, I'm going to say get ability system component, and from here I'm say apply gameplay effect to self. Okay, and I'm going to create this gameplay effect class for this. So right click over here, create a new blueprint class, and it's going to type gameplay effect, this one. So rename this to GE Speed Debuff. Okay, save this and let's open it again, just like this. And I want to add a modifier for this, and this is going to be modifying my speed multiplier. And instead of add, I'm going to actually use override, and the magnitude is going to be like 0.3. So my speed is going to be multiplied by 0.3, and this is going to reduce my original speed. So compile and save this, and I'm going to use this inside of this. Compile and save this as well. And going back to our characters, what I want to do is modify my initial data table, and I have already added this speed multiplier set to 1 and min and max value 0 and 2 respectively. Okay, and next I want to do is open my base character, and over here what I want to do is add a new event for begin play. And what I want to do is create a new variable. I'm going to call this base speed, and this is going to be the type float, and drag out this character movement component and search for get max walk speed, this one. So in this case we're just modifying our walk speed instead of like flying or swimming or anything like that, just dealing with the walk speed over here. And I'm going to store this inside of my base speed. Compile and save this, and next open up your player character. And over here this is a bit different from my previous videos because, well, this is a new project, so yeah, deal with this. And over here what I'm going to do is search for that on speed change, this one. So what I'm going to do is drag out this base speed. And by the way, if you don't see this base speed, and just make sure over here you have this checked, show inherited variables. This will show up over here. So what I want to do is set the character speed. So drag out from character movement and say set max walk speed, this one. So base speed into my speed multiplier is going to be my max walk speed. Okay, and this event is always going to trigger whenever my speed multiplier is being changed. Okay, compile and save this. And now what I'm going to do is drag out this speed debuff and 1. And so when I walk over this, my speed is going to be reduced. So let's go ahead and test this out. And when I walk over this, my speed has been reduced, as you can see. That's not going to go back because I haven't told it to do so. So basically this is it. This is how you send your custom data from your base attribute class using a broadcast from a delegate, and then create a listener for that inside of your character class like this, and create a function that handles the incoming information, and then you can use this in the side of your blueprints like this. Now let's take a look at another example for the speed debuff. Now instead of override, I'm going to change it back to add and say it like -0.1. And what you should see is my speed will gradually decrease over time when I walk over this. So it's 0.9, 0.8, 0.7, 6, 5, 4, 3, 2, 1, and now it should completely stop basically. Okay, so I cannot move any further. So this can be used like for the root kind of debuff where you lock the enemy in place and these kind of effects. So yeah, basically this is it, and this is the way that you use your delegates to send custom data from one C++ class to another. So yeah, thank you very much.